And welcome back to the morning show, 7:25. Time for part 2 of our Wise Guys segment today. Our U of I physics professor, Matt Selin, is here talking about resonance and clocks and how they work and all that good stuff.
Right. So I blabbed on a little too much last time and ran out of time. But, you know, so the whole key was that in a resonance, you have a frequency that something likes to vibrate at. Like a pendulum likes to vibrate at whatever frequency is determined by the length and the strength of gravity.
Sure.
And if you look at an old grandfather clock, you'll hear tick, 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 and what that tick is that there's a little gadget on the top of the pendulum which gives it a little push. When it's over there, it pushes it this way. When it's over there, it pushes it back the other way. Okay, and so the key for having a resonance is that you put motion in, or you give a little push at exactly the right frequency, and that makes the motion bigger. It's like when you're pushing your kid on a swing,
right.
You know that you push the kid, it goes away, he comes back, and you push at exactly the right time, and he swings higher and higher. If you pushed at the wrong time, he wouldn't go anywhere.
Right.
And that's the idea. And so what you'd like to do is to have a much faster resonance. You know, if something just ticks back and forth once a second, the accuracy is limited. If you can get something to tick billions of times every second, then you can have a much higher accuracy, it turns out.
All right.
And so that's where atomic clocks come in. But before we talk about atomic clocks, let's talk about just regular clocks that are like in your computer and in your wristwatch. And if you have a fancy wristwatch, or at least they used to say quartz wristwatch,
right.
Okay, what they really mean is that there's a piece of quartz in there that vibrates, and that's what sets the clock time.
Oh, keeps it on.
Right, and it's just like in a glass. If you have a wine glass, you probably played with these.
Sure.
You get these things and you hear that note. A smaller glass has a higher note, and if you had a little microphone and you put this next to this glass, you could record that sound, you could play that sound back.
I have a little microphone.
Right. There. You could play that sound back through some speakers, and you can make that, through positive feedback, you can make that vibration of the glass sustainable, so it would not stop vibrating ever. Okay, just by picking that sound up and playing it back to it. And the same thing happens. Imagine making this thing smaller and smaller and smaller, you would get a higher and higher pitch. Right now, this pitch is about 1,000 vibrations per second. The kind of clocks that are in electronic devices, wristwatches and computers and things, vibrate at hundreds of millions of times every second. And so I have an example of that over here. This is a little circuit that I built for some research, which is maybe we'll talk about another day.
Okay, sure.
But I've got the little oscilloscope here hooked up to, I hope I do at least, yes I do. You see there's a line that goes up and down and up and down and up and down?
I see that.
Okay. That the bottom horizontal axis of this thing is time. And right in the middle, you'll see that between two of these peaks, there's a peak right there and a peak right there. The distance between those is 10 nanoseconds, 10 billionths of a second.
That's fast.
So it's very, very fast. So that means that repeats 100 million times every second. And that's very typical for the kind of oscillations that are inside computers. And if you were to look at the thing on the circuit board that did that, let me just take this thing right off here. Okay, it's this little guy right here, and that's inside this little guy. There's a piece of quartz, tiny little piece of quartz, that vibrates. And the way the thing vibrates, instead of having sound, is that you put electrical signals into it.
Give it a jump.
Right, and so basically, I'll do this very fast.
Okay.
Quartz, if you squish on it, it gives off electricity. So right here, there's a crystal right in this little thing. There's like a big vise, and if I just cram down on this, see the spark in there?
I did.
Yeah. You get sparks just by squishing on a crystal. Same idea that these barbecue lighters.
Sure.
Hear the little click? You get a little spark at the end of this thing when you click it because you're whacking a crystal and you're getting a very high voltage.
Okay.
That means that you can put a voltage in and you can make the crystal move, and you can get a feedback mechanism by which the thing vibrates, and that's how these work.
All right, very good. We could spend all day on this, but we're out of time.
We probably will.
We can talk about it next week some more.
We will, because I'll talk about it the way atomic clocks work, which uses atoms.
Very good. Okay, Matt Selin, our Wise Guy, thank you very much. If you have questions for Matt, send them to the address on your screen. We'll be back with more of the morning show right after this.